What I'm going to do is going to talk a little bit about why we're doing this and why, what type of problems we are trying to solve with this solution or this service. So in general, we're all heading to a multi-cloud world. We as VMware are doing this, for example, with VMware Cloud on AWS, but also with the container service together with Pivotal, or with Azure with Horizon. But customers are doing the same thing, and we interviewed a lot of customers, and actually IDG and other big consultancy firms did the same thing, and they told us 80% of the customers are actually having a hybrid cloud strategy, right? So they are using VMware on premises, but they are thinking about using Amazon or Azure or Google cloud services for their workloads that run in the cloud. But the reality is that building hybrid clouds, or building just clouds in general, they actually present a lot of challenges. So one of the problem is operational consistency. We're all used to deploy VMs in our VMware data center. However, that's not the same when you deploy a VM on an Azure environment or an EC2 instance of Amazon. It's a different format, right? So you have to change that. And because it's a different format, there's also different management software involved. Different management software means different operational procedures. That is a challenge for a lot of our customers, right? But how do you control and how do you secure those VMs as well? You created a security baseline on-prem. Can you actually apply the same security baseline to your VMs running in cloud? Typically you can't. Every security officer is going nuts, right? And you don't want to have that conversation over and over again with those type of people. Another thing is that you're used to running your enterprise application inside a VMware VM. But now you see those new services of those cloud environments. But can your application actually use those services? Can it use a advanced DNS service? Can it use that load balancing service, right? And on top of that, can it scale, right? A lot of those workloads cannot scale the way the cloud service provider actually intends its workload to scale. So how do you deal with that? So all these challenges are limiting customers to actually deploy a productive and successful multi-cloud strategy. So we looked at these challenges, and we thought we can help the environment, we can help the community. And we started to talk with Amazon. So Amazon, the best data center operator in the world, let's introduce them to the best enterprise software in the world, VMware vSphere, right? So what is it that we actually accomplish? What is it actually what we are building? So what we are doing is we are creating a cloud SDDC. So every customer, so you log on to vmc.vmware.com and you say, I want to deploy a cloud SDDC. Now in that cloud SDDC, you get vSphere for your compute and your memory and just your hypervisor. You get vSAN for your storage layer, and you get NSX for your networking. Now one of the key elements or the key premises is that actually we want to make a low learning curve technology or service. So this is one of the cool things, because you know how to deploy a VM inside your vSphere environment. So this way you can actually deploy a VM in that cloud SDDC as the same way. But now you're storing it on vSAN and you're using NSX for your networking. Now NSX might not be a low learning curve technology, but we will come to that a little bit later in the presentation. So this cloud SDDC runs in the cloud, but it actually has to land somewhere, right? So what we do is we deploy it in an AWS infrastructure. And that allows us to do many, many cool things with AWS. But in reality, if you have deployed your cloud SDDC and you go to the vCenter that runs in that cloud SDDC, you will see something like this. Something you will see, or you have seen for the last 5 or 10 years, is just vCenter. It's just an inventory. Again, you know how this works, so you know how to deploy it. You know how to manage it. You know how to secure it, right? It is just VMs running on an AWS infrastructure. Now, you might notice that we've created 4 ESX hosts, and we have some resource pools, and we have some management VMs running inside that cloud SDDC. This is for every customer, right? Now, you say, okay, is this what we all been talking about? Well, yes and no, because what I've already told about, it's that easy. That's one of the most brilliant things that a lot of customers that are already running on VMware Cloud and AWS tell us. It is so easy for us to actually use that it allows us to actually rethink our data center strategy. And a lot of our customers are thinking about what we like to call a data center zero model, where they get out of the business of actually operating their data centers themselves and basically use AWS infrastructure as an alternative to their own environment. But there are some other things that are interesting about this service. And that is the connectivity to the AWS native services and what we like to call elasticity. During this session, I'm going to talk about the AWS native services and elasticity along the way. Now, I mentioned vCenter, right? So we run vCenter inside the cloud SDDC, but you also have an on-prem environment as well. You might have vCenter running at that environment as well. You can connect those two with hybrid link mode. So Imad described vCenter this morning, but he's also responsible for hybrid link mode at VMware as well. So if you have questions about this, please hit him up. Now, because of that, because we can connect those two vCenters, you actually have what we like to call a single pane of glass with your on-prem and your in-cloud environment in one view. So now you can see everything. Now you can manage everything, right? So the reality of the situation is that you're going to ask yourself this question over and over again for the next couple of years. Where am I going to consume the resources? Where am I going to place the VMs, right? So one of the questions I always get is, okay, so it's cool, Amazon workload, but what workload can I run? It's still cloud, so it's not as good as my data center that I run on-prem. Well, we start off with 4 physical hosts that are only available to you. So every cloud SDDC has hardware resources for you only. You don't share it with any other customer. And this is a overview of the compute specs. So we have 36 physical cores per host. We have 512 gigs of RAM of each host. That is higher than the average, or bigger than the average host configuration, what we see when we look at our customer database, right? So you have this times 4. That means that every cluster you start, every cloud SDDC you deploy, will have 144 physical cores available to run your workload, 2 terabytes of memory. We start off with 4, but we support up to 16 nodes in the cluster with the current service. So the current service is already available in the US, and we're slowly moving to Europe. So if you use 60 nodes, you have 576 cores or physical cores available to run your workload at 2.2 gigahertz each. So can you run your workload? I think you can. Now, one of the things is that, from a CPU perspective, you can, but what about from a storage perspective, right? Is it performing well enough? So we're using a AFA vSAN. We're using 8 NVMe devices on each host. From a capacity perspective, they provide 10 terabytes of raw capacity. Now, it depends on your storage policy how much the VM consumes. By default, in initial availability, that's the service available right now, we're using RAID 1, but you can create a new storage policy that deploys VMs with a RAID 5 storage policy. That means your footprint is reduced tremendously, right? If you go beyond 6 hosts, you actually can deploy RAID 6 for your in your storage policy, right? So we started with 32 devices per cluster, 40 terabytes of raw capacity, AFA performance. It's really fast. If we go on to a full cluster, we have 160 terabytes of raw capacity, right? So what about networking? Per host, 25 gigs. And we deploy network I/O control. So if you have a extremely demanding workload, we still like to provide you with the bandwidth. So we use network I/O control to allow you to get most of the bandwidth for your workloads. Because it's a service and because we deploy these systems for you, we install the software for you, we patch the software, and if there's a problem, we fix that hardware problem as well. Your job will shift from an infrastructure management perspective to a resource management perspective. You don't have to worry about if a host is running, because that's our job. You don't have to care about whether or not it's patched, because that's our job, right? So you only have to think about, okay, so what resources do I have right now? What resources do I need to have? And that's actually an interesting point. So that's what we like to call with the elasticity. So with this, we want to say that you can deploy physical resources almost as fast, or maybe even faster, than you can deploy your VMs on-prem. I did some research and I asked in the community, so what is the average lead time of provisioning a physical host? So from the moment you know you need resources to the moment you actually have it running inside your data center. And I get a lot of different questions. I got different answers. I got answers from 5 days, 15 days, up to 60 days. Now, the fun thing is, there's actually a report floating around that says on average it's 68 days for an enterprise to actually deploy a physical host. That is extremely long. Now, and here's the key thing. If you know that it takes 68 days, you can prepare yourself for it. But typically, it's actually an unpredictable process. Sometimes it takes 2 weeks, sometimes it takes a little bit longer. That can drive you nuts, right? Now, this is the key of working together with AWS, because they have this incredible fleet management. And they use everything, it's basically API driven. Everything is API driven. So that means you can actually deploy physical resources by using an API call. So one of my colleagues actually got hold of an AWS IoT button and started to create some code that actually said, okay, when I click this button, I'm going to actually do a AWS Lambda function, and that will deploy a physical host. He actually also did it with Alexa. So basically he could say to Alexa, Alexa, provide me another host in this data center, but it drove us nuts when he actually started to test this over and over and over again. So by using that button, that was much better. So I actually have a demo, but I don't think you can see it very well, but I just show it what it actually, how it actually works. So let's see if it works actually. Yeah. So here you see add host. We configure the networks. We add it to the vSAN data store. And on the left side, on the top, you actually see, if you look closely, you see now 4 hosts, and now you will see a 5th host. This is a little bit speed up, but it's not far from the truth. It's that fast, right? So I thought this would be a problem, so I actually created in diagrams as well. So by using an API call, and host is added, we will start to configure, or actually scripts will configure your management network, your vMotion network, your vSAN network, and all your logical networks. After that is done, we can communicate with the rest of the cluster, and then we basically add the capacity to the vSAN data store, and the vSAN data store is expanded. From that point on, the DRS will notice that, hey, we've got more resources, let me rebalance the cluster itself. This is all done automatically. Now, not everybody likes to script, sorry Luke, but we also have a UI function as well. So by right-clicking on the cluster, you can actually say resize. And with after that, a new UI comes along and says how many hosts do you actually want to add to your cluster. Now, the interesting thing is we say resize, because what we can do is we also can reduce the number of hosts. So if you think like, hey, I need to have a couple of hosts because Christmas is coming, or the end of the year is coming, or fiscal year is ending is near, we can basically provide you with those hosts for that period of time. And when basically that workload is gone because the period have ended, you basically say resize, reduce the number of hosts. We get the data out of that host, we redistribute that amongst the remaining hosts, and the hosts are gone. Just like that, just by using software. Now what we can do with a click of a button, we can also use it in an algorithm. So what about DRS? So when, at this point in time, DRS works as follows. You set a threshold, and basically that states, if my hosts are unbalanced, redistribute the VMs amongst the other hosts. Now this is all cool, but what happens if you add more and more VMs? At one point you run out of resources, right? Now you have to call up again, say I need another host. It takes up to 80 days. With this, we basically say, let's configure a cluster threshold, and that states what happens if my cluster is loaded up to, or resources consumed up to, for example, 80%, give me another host. So you add more VMs, up to the point that that threshold is exceeded, and at that point, a API call is issued and another host is being added. DRS sees the resources, and everything is redistributed again. Same thing with vSAN. You can also use this if there's a hardware problem. So if a component fails or a host completely fails, what we're going to do is we're going to basically add another host. So HA is enriched as well. So from this point on, we automatically add more hosts when we see a problem occurring. So we see a problem, we add another host, we remove the other host. So the amount of resources you pay for, as you are a customer of the service, that's the number of resources you get, regardless whether there's a hardware problem or not. Same thing with patching. So the moment we need to patch your system, we will add another host, we will remove the host, and we will patch the system for you. The number of resources always stay the same. Who of you, by show of hands, are using AWS already? A few, okay. So one of the most common questions I get from customers is, AWS customers is, okay, so how do you deploy this from an AWS infrastructure perspective? We're deploying it in one AWS region and in one availability zone as of now, right? That means there are some availability questions you can think of, but in general, we take care of the infrastructure. So if a host fails inside that AZ, we will replace it immediately. Typically, this is better than most data centers from the enterprise, but this is not the most optimal situation. So we're working together with AWS to actually create an environment that spans 2 AZs, actually 3, because you need to have another availability zone to run the vSAN witness. Now, for the first time ever, we actually solved the problem of creating hardware resiliency across AZs. Now this is the same thing that we did with introducing HA. So before HA existed, you needed to go into the application and make it highly available per application. Typically that ended up with a lot of errors and a lot of downtime. Well, when I configured those systems, those Microsoft clustering systems, typically the ones that went down the most were those systems. Maybe it was me, but in general I heard that remark from many other people as well. Now we came along with VMware and we told you, you can use HA and you don't have to go into the VM again. You don't have to refactor the application again. You can just click a few boxes on the infrastructure and every VM is highly available. Now, most cloud providers say, don't trust the infrastructure, make your application available again. So we're back to the mid-90s. We say no, let's use us to take care of that. We will make sure that your infrastructure is resilient for an AZ outage, and we will provide you with the functionality and the availability at an infrastructure layer. So how do you get your workload to the cloud? Once you set up and once you spun up your cloud SDDC, how do you get your workload? Now, we start off with initial availability. We have L3 IPsec VPN as of now. That's the only way you can connect to your in-cloud SDDC. But in future releases, we will provide you with an L2 VPN connectivity option or a AWS Direct Connect. AWS Direct Connect provides you with the highest bandwidth. This translates from a migration perspective in a cold migration and in a live migration, which depends on the bandwidth. So with L3 IPsec, we can only provide cold migration. But with L2, we can do a live migration if your bandwidth is plentiful. Direct Connect is typically 10 gigs. That's more than enough. Now, if you say this is all cool, but I don't want to migrate 500 VMs across this line, how do you provide any other services? In a future release, one of the things is what we are going to provide you is HCX technology. And I actually think there was a lab running today of HCX. So one of the cool things with HCX is that it uses a replication form. So you basically say, I want to have this VM migrated to the in-cloud environment. It starts to replicate the data. Once all the data is at the other environment, we do a vMotion or we do another type of migration to actually sync the deltas of the last bits. But the key thing of this thing is that you can do it with almost every supported vSphere environment there is. So started from vSphere 5.1, you can start to migrate to a 6.5 environment. That's basically the stuff that we are running in cloud. If you say, yet I still need to replicate all that data and I don't want to do that, we are working together with AWS, together with a technology called Snowball. And Snowball is basically a very large portable hard disk, which you connect to your data center with normal configuration. So AWS provides you with a Snowball, you connect it in your data center, you shut down your VMs, you migrate your VMs onto that Snowball. That Snowball is being physically shipped to the AWS data center, and then basically they connect it for you, they transfer the data over, and then you power that on. That takes a lot of downtime. What we are doing with SnowMotion is basically using vMotion to vMotion onto a Snowball, use the snapshotting technology again and the deltas. We ship the Snowball over to your data center. We let the data transfer to your environment, and then we vMotion over the deltas to your environment. So you don't have any downtime. This is a solution that is coming in a future release. One of the things that I already described is NSX. Now, VMware Cloud and AWS is built around NSX. And one of the things that what we said is we want to avoid a steep learning curve. Now NSX is not as easy to learn as we want to. So what we thought about was how to reduce that learning curve. And one of the things that we're doing is we are already creating an NSX environment for you. So when you deploy an in-cloud SDDC, we are going to deploy all the NSX bits for you. So the only thing what you have to do is basically create a firewall rule, then add your IP addresses, attach them to your logical networks, and then create your VPN, and you're done. That's it. So that's your low learning curve. You don't have to learn NSX right now. You can basically do this first, then start to get easy and understand NSX, and then basically go further than this. This is what we like to call simplified mode. In a future release, we're going to allow you to toggle to advanced mode, and that allows you to create a full NSX environment. You may remember that I said there are two cool things, elasticity and the connectivity to cloud-native AWS services. Now this is the other one, the connectivity to the AWS services. So AWS allows us to directly connect to particular AWS services from your in-cloud SDDC. With the initial availability, we allow you to connect to S3 and EC2. That means if you run a VM in cloud and that connects to an S3 bucket, it doesn't leave the network. It doesn't go to the internet and comes back to the AWS environment. No, it natively goes across the same network directly to that S3 bucket. That means you have incredible performance, but you don't incur egress costs. So this is insanely cheap to actually build, because one of the most challenging things is controlling the egress costs. Another thing is EC2 instances. Now you can create an environment that uses virtual machines from VMware and EC2 instances from AWS, and they can connect across the same network, so they have a low latency connection between each other. You can create really cool application landscapes. Now this is from an initial availability perspective. As we go along and as we increase our service, we also include more and more native AWS services. So with every new, what we like to call release or milestone, you will see more services added. If you want to know more, go to the website or use some hands-on labs. But one of the cool things is somebody posted a catalog of all the VMware videos of the sessions of this year's when it comes to VMC. So just go to medium.com and search for highlights VMware Cloud and AWS, and you will find it instead of typing this in. Or go to the repository of William Lamb on GitHub. He has posted all the sessions as well.